depending on where you are. Setting up an animation curve to basically automate a trajectory of a projectile. It just makes things very easy to just define how a projectile will fly through the air in whatever game you might be writing in Unity. So you can see I have set a little ball here, and if I run this program, if I click any point on this ground surface here, you'll see it will move the ball. Fly through the air with a nice curve to it, bring it back to the starting position again, close to it. Now it moves quite slowly because this ground plane is 10 by 10. If I move it a short distance, you can see it jumps really quite quickly. Okay, so how do we do this? Well, we'll do a new project and start from the very beginning, and I'll show you exactly what to do. Because there are basically three principles in all of this. First off, we have to transform where the mouse clicks on the ground and find a position where that is on the ground. The next thing we have to do is work out a vector from where the ball starts, so say the ball is starting from here, to the point where we click, and there will be a vector in this direction to that point where we want the ball to land. The next thing we have to do is we have to apply an animation curve that will define the actual height of the ball in the trajectory that we want it to go in. And that can be any shape we like. I'll show you exactly how to do that. So then the next thing we have to do is set up some sort of automation to animate the ball. And the way I've done that is by having a coroutine. You could do it in the fixed update, but you may want to use fixed update for lots of other things. So it's best to probably keep the animation of this ball separate. That way you can have several balls or objects, projectiles, whatever you like, and they'll each have their own coroutine, could even have their own curve. Okay, so let's start. Okay, so what we will do is we start with a fresh new project. This is just using the default layout screen, and to complete the new project, haven't added anything yet. So the first thing we'll do in the hierarchy here, we'll create a ground to put the ball on. So let's just use a plane. The plane will do just fine, and we'll say it's 10 by 10 by 10, give us a nice lot of space here, and then we can just give it a colour so it doesn't look so bland. So why don't we create a new folder and call that our materials. Create folder, call it materials, and in that folder we'll have a thing called a material called, say, ground, and we've got to pick a colour for it over here, say some sort of green colour like that, and we can just drag it across. There we go. Maybe make it a bit darker, it's a little bit garish. Okay, alright, we'll have that as our colour, and we'll drop off the smoothness so it doesn't reflect anything. Grass doesn't really look very shiny. Okay, so the next thing we'll need is we'll need our ball. So we'll create a sphere, and we'll leave it scale as 1:1, that'll do. We can have a material for that too. So let's create another material, and we'll give it a red colour. So red, nice bright red. Let's just drag those across. Okay, red, no green and no blue. And we can make the ball nice and shiny too if we want. Let's just, I must have cleared that, sorry. That's the colour we want. And make it nice and shiny. And just drag it across. Now you notice the ball's embedded in the ground, so we need to basically just set its Y position. Seeing it's a unit sphere, we'll make it Y position just 0.5. That'll just set it on the ground there. So if we look at the ball now, we can see it's just sitting on the ground. Okay, So now what we want to do is we want to be able to click anywhere on this surface here in the game screen, and have the ball fly through the air with some magic curve, which we will define, an arc if you like, and stop at the position where we have selected on the ground. Okay, so what we'll need a script. So that means we'll need a new folder here in our assets. We'll create a new folder. Got to keep this all nice and neat, keep things separate. We'll call this folder scripts, and in the scripts folder we will create a C# script, and we'll call it, what do we call it? We'll call it ball motion. Ball motion. Now, first thing we'll do is we will associate this script with the ball, so we can just drag it straight across onto the sphere. In fact, we'll rename it. We'll call it a ball. Seeing it is a ball. And now we see over here it has a script associated with the ball called ball motion. So we'll open that script now. Takes a little while. Okay, so now we have our standard initialization of the script. Now we won't need the start, so we'll get rid of that. But what we'll need to do, let's give it a comment here. What we will need to do up the top here is we will need to actually define our camera. So we'll use serialized field. Now if you don't know what serialized field does, it is simply it's a little mechanism in the software here in the Unity engine, which basically will allow the next variable, which we'll call camera. That's camera. It's type camera actually. Type camera. We'll just call it cam. It will put that in the inspector, so we can actually drag the camera object down onto that to make it accessible inside this inside the script. The next thing we'll want, serialized field. The next thing we'll want is the actual animation curve itself. Animation curve. Animation curve, and we'll call it, what do we call it? Let's call it curve. Okay, so we can just start with this now. Just save this. Make sure you save it. If you don't, it won't update in the Unity over here. And you see it reloading. Now if we select ball, we can see in our ball motion script there is now a camera, which we have to drag our main camera to. So click our main camera, click and drag actually, don't just click it, but click and drag over to here. So now our camera is defined, but our curve is blank. So if we just click on the curve window there, we can see we have this nice window where we can define what our curve is going to be. So we have these predefined down here. We'll just select a line. Now we'll position this at 0. It starts at 0. The animation won't start in the middle of the air. We just go edit key and just set OK. Well, at time 0 we want the value to be 0. So that's fine. And at the end we'll say edit key at time equals 1. We'll say the value is 0 again, because it'll end up on the ground at the end of our trajectory. Then right in the middle, if we double click, it'll make a key, so that we can drag this curve up, make a nice parabolic arc. It looks a bit like a parabol. But you can make this shape whatever you like, as long as it starts at 0 and ends at 1, goes up to a height of 1, you can see here. So this whole curve just defines the shape that we want to have. We can close this box now. So now we have in our inspector window, we have the little image of the curve that we've just defined. Now that's the curve shape we want our ball to follow. Okay, so the next thing we do is we go back to our script. We'll just Control S to save this. Go back to our Unity script. Now what we need to do is we need to define a couple of things. First of all, we'll want to have we'll have a variable that defines the speed for our ball. So we'll have a float. Now these will be private, so I might as well say private at the beginning. They don't need to be made public. So we'll make ball speed. Now you could, we'll set it to an initial value and say 10. Now you could make this serialized so that you can change it in the inspector. That way when the program's actually running, you could change this speed without having to re-edit and then restart. But for now we'll just leave it the way it is. Now the next thing we'll need is a height that we want our ball to go to. So we'll call it another private float ball height, and we'll say, we can say 10 for that as well. So that's how high the ball will go. You notice in that animation curve, the animation curve here, it only went to 1. So what we have to do is, it starts at 0 and ends at 1, that's going to be the distance. So we're going to have to scale the distance for whatever distance we want the ball to travel, and we will scale this height by ball height, which we've just defined in our script. So, okay, so the next thing we need to do is we need to have some sort of vector that defines our endpoint. So we'll define that here. It's going to be a vector 3, it's in 3-dimensional space, and we'll just call it endpoint. Okay, now in our update, this is where we want to look for a mouse click to see where it actually hits on the ground. So all we do is we basically just saying if we have input mouse, actually it's not mouse, it's get mouse button down, and we want to look for the first button, which would be that'll be the left button. Now with our mouse button pressed, this is where we want to find out where the mouse has clicked on the plane, on the ground. So we have to basically cast a ray. First off, we will define a thing called a Raycast Hit. And what this will do is it will hold information about what the ray will actually hit. So we'll just call it ray hit. And what we need now to define is a ray. The ray itself, and the ray itself will be in the direction the camera is facing. Now we already know what the camera is because we passed it up the top. So that could be cam, and what we need to cast is we need to get the screen point from where we're going to cast the ray. So screen point to ray, and the input to this will be the mouse position. So input dot mouse position. Now what this will do, if you can imagine the camera say pointing at the ground like in so slanting angle like that, it will make a vector that is pointing in that direction, but through the frustum that the camera is looking at. So if we go back to Unity and have a look in our view here, we can see we have the camera. Now if you look at the way the camera has got this box shape. Now if you look very closely at the camera, you can see there's a little rectangular area right near the camera itself. Now where you click on the surface will be where you are clicking on the screen. So if we click, you can see where my cursor is here. That's the view that the camera sees through this viewpoint. If we click on the screen at, say, this point here, it will be a little point on this part of the frustum here, and it will cast a line from there to the ground surface. So it'll actually be a vector. It'll be a vector that just consists of the starting position, which is here, and a direction, the direction in which the ray will be cast that hits the ground. So that's basically how this screen point to ray actually works. So the ray just simply consists of a we've got to define our ray, haven't we? Ray. Okay. A ray just simply consists of the starting point and a vector in the direction of the ray. That's all that is. That's not magic, some sort of ray gun or something like that. It's just a position and a direction. Okay, so now that we have that, we need to actually cast a ray. Now what casting a ray does is simply treating the ray as an imaginary line. Go back to Unity again. It just simply has this imaginary line that's been defined by the position and the direction, and it looks at points along that line and sees if it intersects with a collider anywhere. And we have a collider on our plane. If we look at our plane here, which we could call ground actually. When we call it ground, rename it to ground, we will see it has a collider. If we don't have a collider, the ray will not hit anything. So we need to have a collider, and that's put in automatically for us when we selected the ground being a plane object. So now if we go back to our script, what we need to do now, the next step, is we need to actually cast the ray. So if we say Raycast, it's physics. It's part of the physics object. It's a method of the physics object. So Raycast, and we need to say what the ray is, which we've just defined. So it's a ray. And what we need to do is get back from the Raycast information about what it's hit. That's what this Raycast Hit object is at the top here. So we put in our Raycast Hit. First off, we have to say out, and then ray hit. Now the out means that this function, method at least, will return back information into this variable ray hit. And we can make an if statement out of this, because if nothing is hit, this raycast will return a false. So if we say if physics raycast hit, that will mean it's true if it gets into these brackets here. If the if is true, it means something has been hit. Now, what we need to do is set the endpoint of what actually was hit. We've defined our vector3 endpoint up here. So endpoint will equal our ray hit, and we just need the point. That'll be a three-dimensional point. If we see here, the point is returned as a vector3. So we just need the point. Actually, that's not a method. It's only a returns it to get set. So there we go. Okay, so now at this point, we have the end point and the starting point. We know, because that's going to be the position of the ball. Okay, now starting coroutines in this sort of situation can be a bit tricky, because we only want the coroutine to run just the once when we click the surface, and not run again until the ball has actually finished the transit through the arc. So you could just start a coroutine like this. So start coroutine, and then you have the name of it. We'll call it follow curve. You could do that, but that would mean every time you click on the surface, every time the mouse down is on the surface, it'll start a coroutine. So I don't like this, the way to do this. A much better way is if we define up here an enumerator, and call it, say, coroutine, and set it to be null initially. Set it to be null, meaning there is no coroutine running. So now what we do here, instead of this, we say, okay, what we will say now is if the coroutine equals null, then we know the coroutine is not running. If it is running, we will just exit out this update and not start the coroutine. So if it is running, if it isn't running, we now then say coroutine equals, and the name of our coroutine. And we're going to call it follow curve, aren't we? Follow curve. So that'll call the coroutine method and return back an enumerator straight away to this enumerator variable here. So now at this point we can now start our coroutine using our coroutine variable that we've just set. Okay, so that is a safe way of guaranteeing we'll only run the coroutine once. Now, just to save some time, I've actually already entered in the function for the coroutine, or the method I should say. Don't talk about functions in C#. So follow curve is our enumerator coroutine, which gets called here and returns back a coroutine. This is a very special way. You normally don't call coroutines, you start them. But if you call it like this, it will return back this enumerator, which we can then actually use later. Because I really don't like calling things by these strings, these names, because what if you change the name of this and you have the string for the name in here? Then you have to go and change it. What if it's done in multiple places? So I prefer to do it this way, and it's also a safe way of making sure the coroutine does not get started multiple times. Okay, so in our coroutine, the very first thing we need to do is we need to set up a little vector that defines the path from the start where the ball is to the end position. And to do that, in vector math, you always subtract the start position from the end position. If you do it the other way around, you'll get the vector pointing the opposite way. So it's got to be end point minus start point. If you get confused by that, think of a point of an origin, and so the point at say 1 1, which would be up here somewhere. If you subtract 1 1 from 0 0, you get minus 1 which is down here. So you always subtract the start position from the end position, and that will give you a vector in the correct direction. Now what we need now is a total distance of the travel from the start to the end, and that's just going to be the magnitude of the vector. After that, we just normalise this path vector. We need to normalise it here so it's only got a unit in magnitude. I'll explain why that is in just a moment. We need two more variables. We need one which defines the distance. It keeps a tally of the distance travelled from one frame to the next frame. Because this will basically loop around every frame from this while. This will basically loop around every frame, updating the position of the ball. So we need to have something which keeps track of the distance travelled. The next thing we need, we'll just calculate what the ball radius is. As I explained earlier, if we go back here in our animation curve, the height starts at 0, goes to 1, and then back down to 0 again. So if we set the position of the ball at 0, as we saw earlier when we created this ball, it was buried in the ground. So we need to add the radius to this height here. We also need to scale this whole curve for whatever the ball height is that we've defined. So it only goes to 1. And the other thing we need to scale is the distance. Because it goes from 0 to 1, we need to scale this distance to be whatever the distance is that the ball is travelling. I know that this all sounds a bit complicated, but it's really quite straightforward. Go back in here and have a look. So here we calculate the ball radius, which is the transform local scale. Now, because it's a ball, X, Y, and Z are just, they're the same, because it's a ball. But we'll just use Y here because we're really thinking about the height of the ball, which is on the Y axis. So we divide that by 2, and it gives us the radius. The last thing we need here is a new position, a vector of the new position that the ball will be. Now this position is a 3-dimensional vector. So it'll just initially be wherever the ball is, the transform position. So we'll set that, that's just initializing our new position to be where we start from. Now we do our loop, this magic loop, which basically just iterates around until our distance travelled is less than or equal to the total distance that we've calculated up here. So we need a new vector 3 for a small amount of path, because this will be added each time we go around to our new position. And our delta path is just going to be the path vector, which is our normalised vector which points in the direction we want to go. And we multiply by the ball speed times delta time. And the delta time, of course, is just the time between each frame. So if you have a frame rate, a very low frame rate, this value here will be a large value. If you have a very fast frame rate, this value will be low. So the idea behind this is that on a slow frame rate machine, the movement of the ball will appear to be the same as on a machine that has a fast frame rate because of this delta time. So now we have a new position of the ball. We just add on whatever this little delta amount is. This is the new position. To that, after that, we just basically add on to our distance travelled, which is just the magnitude of this small delta of the movement of the ball for this particular frame. Now, the new position, it's really, this calculation above is really only in the 2 dimensions of the ground from one point to the next point, because they're on the same they're on the same vertical level, because it's a flat plane. What we want to actually find out now is the height that the ball goes to, and that's where our magic curve comes in that we've set up, our animation curve. First off, we have to make sure we don't go any less than ball radius so that the ball doesn't get buried. Then we need to get the value of our curve in the vertical and multiply by the height, because remember the vertical of our curve is only 1, so we have to multiply by our ball height. And the evaluate sounds complex, but I'll go back to our animation and explain this a little bit. Evaluate simply gets a number between 0 and 1, and it evaluates the y position of this curve for each position along here, from 0 to 1. That's really all the evaluate does. It's not no more complicated than that. And remember, this animation curve can be in any direction. If you think of a flat plane, a vertical plane, pointing in any direction, and the animation curve will follow no matter which direction it is, depending on the start point and the end point. The start point could be here, end point could be over here, or start point could be here, and end point could be over here. So the animation curve will follow a plane between those 2 points. That's the way to think about it. So now we have a y position, or a height, for our ball, which is the ball radius plus this the curve position times our height. Then we just simply set the ball's position to be this new position. Now the last thing we have to do is make sure we do a yield return on this loop. Otherwise our coroutine will not act like a coroutine. It'll freeze the whole computer. We need to make sure we relinquish control between each frame of this coroutine until it's finished. And that's basically what this yield return null does. The null just simply means that it will come back at the next frame. The yield returns in coroutines, you could have wait for seconds, so many seconds, or you can even wait for another coroutine. You can start another coroutine and wait till it's finished. But it doesn't just sit here waiting. It frees up and lets other things run. And then when that other thing is finished, it comes back. So that's what's so good about these coroutines. Now when this is finished, when it's got to its total distance, the ball has reached its destination, we need to set our coroutine variable back to null at this point. That way, when we click on the screen again, we'll see our coroutine is null, and then we can restart it. We can restart it here. If we don't set it back to null, this will never happen. So we'll only be able to click on the ball once. So that should be all we need to do. It's really not that complicated. So if we go back to our Unity now, we'll just make sure we have saved all of this. Go back to our Unity now, and I'll just make the screen, the game screen, large. Now if we click anywhere on the screen now, there we can see our ball is jumping. If we set a point way over here, you can see it takes a long time to get there. It's a long way away. And we can just set a point here, and set a point anywhere. Set a point here, and oh yeah, see, that wasn't very far away. It wasn't very far away, so it looks like it moves very quickly. But notice, if I click on the screen now anywhere, it doesn't interfere with the ball's movement, not until it's stopped. And that's where we're checking for the coroutine variable to be null. So anyway, look, that shows how you can move things, projectiles and things in Unity really quite in a straightforward manner. One last thing, the ball does not have a rigid body. It could have, but because it's being moved by the animation and we're setting the transform position, we do not need to have a rigid body. But of course, if you wanted to have the effects of gravity and all those sorts of things, then yes, you would need to have a rigid body, but the animation should still work the way it is. So I hope this has been of some help to some people out there, and let me know in your comments if you don't understand anything or need something explained a little bit better. Thanks very much.